Topic 4. The design and implementation phases of the systems development lifecycle. You are very welcome. My name is Maureen Neal. As before, please keep in mind what you have shared and learned together in the earlier topics 1, 2 and 3. It's very relevant as we finish this online course here today with topic 4. We are now going to take an overview look at the last two phases of the systems development lifecycle, which are number 1, design, and then finally implementation. The design stage offers a new system design that will meet the functional design requirements, which are the output of the previous stage, which is the analysis stage. This is perhaps the most creative stage of the overall process or waterfall method for systems design. There are 5 key areas or aspects which we will now look at. The first is systems architecture. The first task is to specify the structure of the systems architecture, and by this we mean what platforms the system will reside on. There are numerous components that contribute to the systems architecture. So this includes the database, programming language, front-end language, architecture levels, operating system, network implications, and the different types of servers. So a couple of examples could be we're going to use Oracle databases. Oracle is a company. The programming languages that we're going to use, well, for our database, we're going to use SQL. For our back-end systems, we're going to use Java. And for some of our front-end design, we're going to use Python. The operating system that we will operate this system on will be on a Windows-based system, so it's a Microsoft Windows. The architecture is usually chosen by the project manager and the systems designer, and it has to consider things like budgets, existing systems, capacity, and skills. The decisions made here also involve much consultation with both internal and external experts, and sometimes system suppliers themselves, so the likes of Microsoft or Oracle. The next aspect we will consider is subsystems design. So it's commonplace to divide the systems into a number of discrete, manageable functions called subsystems. This allows the project to be managed more easily, and it allows for multiple development and testing teams to work in parallel later on. So these systems are derived from the process models and documentation created at the systems analysis stage. So an example of 2 types of subsystems could be, you could have a subsystem that's concerned with all the inputs to the system. So where a customer applies for a loan, that would be considered to be an input. So that could be one subsystem, is something deals with all the inputs into the system. Second subsystem could be something that deals with all the outputs. So for example, when somebody applies for a loan, the output of that is that there's a process that kicks in where the loans are approved on the system. So you could see that could be the outputs of the inputs, for want of a better word, could be another subsystem. The next aspect we're going to look at is system interfaces. The designer also needs to look and design how the new system will interface or connect with other systems or processes that it will depend on or need to operate with. So there's broadly 4 different types of interfaces. One interface is batch interfaces from other systems. So there is a possibility that the new system will need to be able to accept or send information from or to other systems. So an example here could be a new online loan approval system. Well, it will need to talk to a program that the bank already has, which is like an existing direct debit system that sends out direct debits in batches each month to collect the monthly payments. So the new system will need to talk to existing systems to make sure that that happens. The second interface could be that the new system needs to retrieve information from other areas or systems in real time. So for example, if a new banking system allows the customers to take cash out of an ATM using their card, then real time the customer's balance in the bank's back-end existing accounting system needs to be reviewed and updated to ensure that that transaction can take place, that the customer has enough money and that it knows how much more they can take out if they don't come and use an ATM again. The third system interface is inputs that are allowed to the new system. So an example here would be, what documents must a customer upload so that the bank can identify them, in order to help them open their bank account. So for example, they might say, well, the only input that we can take is a passport. We can't take your college ID. So rules will be built in at the design stage for what inputs the system will be able to take. Finally, the last system interface is outputs from the system. So the designer also needs to make a decision on the output methods allowed from the system. So normal output mechanisms include what sort of data will be displayed on the screen that the user will see. It could also be, do we want the system to do anything, to send anything out after a transaction has happened? So emails could be something that would be an output of the system. They could be sent out confirming, for example, loan decisions. The next aspect which we will look at is usability. So users will be heavily involved in this design phase, as they'll be working with the designer to ensure that the system is usable. And we've touched on this earlier on, it's absolutely critical. So this involves looking at the screen design and the human interaction aspect of what the system will be. So for example, does the system work for disabled users? Because if it doesn't, it might need to be tweaked to accommodate some people with certain disabilities. Does the help system need to be improved, now that the users have given some input? Was there some things that the designer didn't think of that the user thought of? That side of things. At this stage, prototyping can also be used, where the designer creates a refined version of the proposed system. That's what a prototype is. The version will probably do very little processing, but should have enough detail in it to give the idea some user of what the end delivered system will actually look like. So the final aspect in the design phase is around security and performance. So they need to be addressed, and this can involve looking at how the users will access the system, how the system will authenticate and authorize each user, and it'll also ensure that proper auditing procedures are in place to make sure that users are accessing the system correctly, that they're not able to access parts of the system that they shouldn't be able to get in. So aspects that would be covered here would be, for example, that the system user's password and PIN, so they're needed every time they access the system, but they must be changed every 60 days. Another performance aspect that will be considered here is this is an online system, so it needs to be available 24 hours a day, 7 days a week. The final ask for the designer is to create a series of detailed design documents. These are normally tied in with the various subsystems, and each subsystem will have one or many documents attached to it. These documents should describe in some detail all of the functions that will be carried out within the subsystems, the screens, the programs that will be used, the interfaces. Once these documents are signed off, and that involves the users and the business owners, they are given to the appropriate development and testing team to kick off the final stage. Implementation. This final stage is a really busy one, when all of the work from the past 3 phases comes to fruition as the new system is built, tested, and then goes live. Really, this stage should be where the business owner gets to see the delivery of what they visualized for this system at the very outset, back in the planning stage. The build phase. There's 4 key aspects here that we'll cover today. So build is the first one. There are sometimes different development teams that contribute to the creation of the new system. So these include the front-end development team, the database team, technical architecture teams, and teams from the operations department. The team can consist of a mixture of designers, analysts, senior programmers, junior programmers, and specialised development testers. It really does just depend really on the size of the project. There's lots of writing of code, lots of testing of code, and lots of quality checking of the code that's been written and tested. There are numerous documents used during this stage, and they include program specifications, unit test plans, and string test plan documentation. Testing is the next key aspect, and there's really 3 phases to testing. The first phase is called system testing, and this ensures that the system is working properly as a whole and that there are no major gaps in functionality. So that, for example, the new systems talk to each other correctly. So the new system talks to the direct debit system that we spoke about a little bit earlier. The next phase is user acceptance testing. And this looks at all of the functionality in the system and ensures that every single part of the system operates in the correct way and that it handles invalid operations correctly. So, for example, in user testing, you have to make sure that the end users don't get unexplained error messages when they're using the system. The last testing phase is pre-live tests, and it really ensures that the system can operate on live volumes of data. So if we believe that we'll have no more than 200 users using the system at any one time, we have to find a way to test that that actually does happen in reality. Next comes training. So the project manager should finally ensure that the eventual users of the system are educated and trained so that they will be able to use it once it's in production. The education aspect is concerned with informing the users about the system, what it will do, when it will be available, and how their work practices will be affected. The training part lets the users play with the system to allow them to get a feel for how it works before they have to use it in a live environment. And some customers do involve customers, actually real life customers, in this aspect of designing their new systems. The last key aspect here is the implementation go live phase. The implementation phase is mostly concerned with getting the new system that has been developed and tested successfully installed live and released to all the business units throughout the organisation. It's normally referred to as well as a conversion process. This conversion process should have minimal disturbance on the company itself, and it's usually done over a weekend or during a holiday period. The teams involved during the conversion process include operations, technical architecture, conversion development, business users, and the project manager themselves will be on hand throughout. In fact, the responsibility for ensuring the new system is implemented correctly does lie with the project manager, and they need to ensure that after the conversion period has ended, the new system is ready to be used across the organisation with no problems. The project manager should report back to the business owner's project board on how the conversion period went, any issues that still remain in the system, and how the project went overall. It's a very, very busy time for a project manager, and one where there's a lot of pressure involved sometimes. After the project has been implemented, what really happens is that the system is now in the live environment. The key outputs really from this phase is that there needs to be now a team in place to own and manage the system in the live environment. There's certainly much more course material on this and separate courses that you can pursue if you want to learn more about how things operate in this environment. It's important as well that once a system is implemented, the business owner will expect to see the benefits that they were planned initially to be delivered, and they will monitor the new system and tweak it until those benefits are delivered and then build upon that as time moves on. At this point as well, all of the different people we've talked about, the roles, the project manager, the systems analyst, the systems designer, the programmers, all of those people will now move on probably to other projects and to develop other new systems and probably put them through a very similar type of process for managing them. So that's the end of topic 4 in this course. Thank you.